Okay, so when is sine theta equal to 0? Remember, it's when theta is equal to pi n, where n is any integer. Cosine is when theta is equal to pi over 2 plus pi n plus every half a rotation. Tangent is equal to -1 when theta is equal to 3 pi over 2, over 4 plus pi n, and -1 or +1 when theta is equal to pi over 4 plus pi n. Okay, on the unit circle, pi over 4 is 45 degrees. Negative slope would be -45 degrees. Oh, -45 degrees, or 3 pi over 4. All right, where is cosecant undefined? It's when sine x is equal to 0. So that for us would be when theta, or x in this case, is equal to pi n, which means that the domain is we cannot equal pi n. The range is between for the mother is -infinity to 1. So y is between -infinity to 1, with 1 being included, or from 1 to infinity. The symmetry is odd, so this is an odd function. The period is 2 pi, just like sine or cosine. And the vertical asymptotes are related to our domain, so when x is equal to pi n. All right, so check it out. Since cosecant is the reciprocal of sine, what we do is we graph in the sine function. So I'm going to go ahead and graph in the mother function for sine. 4 split into 4s. So from 0 to 2 pi is 1 cycle. So pi is the middle, pi over 2, and 3 pi over 2. Okay, I'm going to make this 1 and -1. So the mother function for sine starts at 0, goes up to our midpoint or high point, back to our midline, low point, midline. I'm going to extend it backwards, 1, 2, for another cycle. So we're going to go -1. Okay, so we look like this. Okay, so anywhere there's a 0, 1, 2, 3, 4, 5, we have an asymptote. So at -2 pi, at -pi, at 0 pi, surprise, not really. Okay, 2 pi, we have an asymptote. What is the reciprocal of 1? It's 1. What is the reciprocal of 1? It is 1. What is the reciprocal of -1? It is -1. What is the reciprocal of -1 again? -1. All right, but what's the reciprocal of a fraction? So like the reciprocal of 1/2 would be 2. So this point right here is actually going to double in size. So what happens is all these fractions are actually going to become larger numbers. So the part above the sine graph is our cosecant graph. Boom, 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 boom. So it's hard to tell, but only the green part is actually the cosecant graph. It looks like teeth, okay? Like teeth. For secant, it's related to cosine. So I'm going to start by graphing my cosine function. Boom, boom. 1, 2, 3, 4. 1, 2, 3, 4. Normal period of 2 pi to -2 pi. And this time, I'm going to graph my 1 unit here, -1 unit here. Cosine starts high, mid, low, mid, high, and then reverses itself. Okay? Anywhere there's a 0, we're going to put in an asymptote. So anywhere there's a 0 on the cosine. Okay? Any high point on the cosine graph becomes a minimum on the secant graph. Okay? Low points become a maximum. Then we just draw in our teeth. Teeth, teeth, making sure we don't touch the y, the vertical asymptotes. Okay, so we say that secant has, we can't divide by when cosine x equals 0. So remember that is when we have x or theta is equal to pi over 2 plus pi n. So we're going to look at our graph and be like, yup, pi over 2 plus pi plus another pi minus pi minus pi. Okay, so x cannot equal pi over 2 plus pi n. The range is between, so from negative infinity to our high point, so negative infinity, y is negative infinity to negative 1. And then from, oops, this should be a negative right there, negative 1. And 1 to infinity. The symmetry, this one is our first even function in a while. The period is 2 pi, the vertical asymptotes are pi halves plus pi n. All right, so this time we're going to look at the sine function, 2 sine of x plus 4 in Desmos. So let's see what we got. Okay, in Desmos. And you can see, it looks like our normal sine function. It goes up an amplitude of 2, down to an amplitude of negative 2. It's like been transformed a little bit by a horizontal shift of negative 1/4. Okay, we're going to graph in our cosecant graph because they are reciprocals. Boom, looks like teeth. Okay, this cosecant graph is really just the blue. Okay, but when I see you graph it, I want to see those asymptotes. I want to see the sine graph so that I can see how you got your graph. Okay, so what we see is that I'm not going to graph it there, but we see that the midline, any point on the midline becomes an asymptote, and any relative min becomes a relative max, and any relative max becomes the relative min of the teeth. Okay, so what we're going to do first is to graph the reciprocal. So the reciprocal of secant would be the not the cosecant, the cosine of 2x. So I'm going to do like the amplitude is 1, the midline is 0, the period is 2 pi over the speed, which is 2, so a period of pi. The left asymptote is going to be, or the left end of the cycle, and the right end of the cycle is 2x is equal to 0, and 2x is equal to 2 pi, our normal cycle. So x is equal to 0, and x is equal to pi. So go ahead and start that. We're going to start our graph at 0, count up by quarters to pi, and then back to negative pi. And I'm going to see that the middle is pi over 2, pi quarters, 3 pi quarters, negative 3 pi fourths, pi fourths. Okay, so the next thing to do is just to graph in the cosine graph. The midline is at 0, and the amplitude is 1. So I'm going to go 1, negative 1. Cosine starts at the high point, goes to the midpoint, down to the low, mid, high, mid, low, mid, high. It continues on. Okay. From there, I'm going to make any midline point into an asymptote. So make that into an asymptote. My midline is at 0. So that's nice and easy for me. Okay. And then I'm going to go ahead and graph in my highs become my minimums. And I graph in my tooth. My low point becomes my high point. Graph in my tooth, 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 tooth. And that's it. All right, so the cosecant of pi over 4x plus 8 pi. I'm going to throw in a wrench and say plus 1. Okay, so I need to graph in the reciprocal of cosecant, which would be the sine of pi over 4x minus 8 pi plus 1. So my midline is 1. My amplitude is 1. The period is 2 pi over the rate, which is pi over 4. So I'm going to multiply by 4 over pi, giving me 4 over pi. Cancels. All that cancels. Whew, giving me 8. Ooh, 8 is nice. Okay, so left end point and right end point of our first cycle is pi force x minus 8 pi is equal to 0, and pi force x minus 8 pi is equal to 2 pi. So we're going to add 8 pi, giving us pi force is equal to 8 pi, pi force x, and then multiply by 4 over pi. Pi is cancels, to give me 8 times 4 is 32. That was kind of evil. Okay. So next we're going to do add 8 pi. So pi force equals 10 pi, multiply by 4 over pi. Cancel my pi's. So pi force is equal to 40. So we've been transformed way, way, way over to the right. So I think I'm going to go ahead and count up by, I'm going to take out my x-axis. That's what I'm going to do. Yeah. So what I'm going to do is just start here on this x equals 32. And then I need to split up 32. So 8 units happen between 32 and 40. So I'm going to split this up by 2. 34, 36, 38, 40, 42, 44, 46, 48, 50. All right. So I'm going to be going, my midline is at 1, and my amplitude is up 1 and down 1. So that's what my, okay, so at the left end point, since this is sine, we're going to start at the midline, go up to the high point, to the midline, down to the high point, low point, midline, high point, midline, low point. Okay, so I have myself a sketch. This time, because our midline is at 1, we're going to make sure that our asymptotes are going to be graphed anytime the graph touches the midline. So at 32, 36, 40, yeah, that's one full cycle. 44, can continue this cycle. 46, or 48, sorry. All right, our highs become our lows, and we graph in our tooth. Our lows become our highs. We graph in our tooth. Tooth, 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 tooth. Ooh, that one's not very pretty. And that is it. That is secant and cosecant graphs.